Okay, we have two problems. The one that is really a quiz problem for today is this one. These two, I'm trying to see what you know, because these are coming up like this week, real soon, like some up by Wednesday. Okay. So first place. Two. Okay, so just kind of tell me, thumbs up or thumbs down, okay? Then be ready to vote. Just give me your quick answers. Should I add the 3 to 5? Yes or no? Okay. No, why not? Because this 3 is divided into something, this 5 isn't. Okay, you have to do this division. You have to divide by 3 before you can add that 5. Okay. It will apply the 2 by 4. Okay. Nope. Okay. So you got it, some you didn't. Because the 4 is raised to the second power. You have to exponentiate before you multiply. Okay. And I can't subtract the 3 from the 2 either. Okay, again, because it's involved in a division. Okay, so what I have to do is first I exponentiate. I'll abbreviate that. Okay. I'm going to have get this. So what I just did was part of the section gave me 16. Okay, now what do? I can multiply. I can do my multiplications and divisions. Okay, what do I multiply? Well, I can multiply 2 by 16. And I can divide 3 by 3. That minus sign is included in the division. It's a little careless way to circle that. Well, 2 times 16 is 32. 3 times 3 is 1. I have that minus that plus 5. And now it's easy. Okay. We can add and subtract. Just left to right. 32 minus 1 is 31. So I'm going to do that in 2 steps, although you can easily do it in one. And so 32 minus 1 gives us 31. So officially that's 31 plus 5. And that's 36. This equals this. All the way down to here. Your answer is 36. Now, if you put that into your calculator, if you just press these buttons, that's what you're going to get. If your calculator is obeying the order of operations. And I think almost all of them do. Now, their Excel doesn't do order of operations correctly because it was written by accountants, not by mathematicians. Okay. And they just didn't bother, whoever buys the thing, didn't bother to respect the order of operations. So it can be confusing. So you have an assignment on that. And you already have an order of operations with fractions that was due today. Okay. And if I look to see if everybody did it, see what I find out here. Order of operations with fractions. Yeah. 2 out of 3 of the class did it. But and made 100% off. Okay. Well, you're gonna, and actually, I think there's another order of operations assignment. And everybody made 100% on that. That did it. Two out of three people did it. Okay. If you didn't do it, go to the half credit, pay if you do it, I'll still give you full credit. You got it done by Wednesday, okay? Now, this brings up the question of how everybody made 100%, but didn't always get the operations here. So you probably want to review it. Make sure you have it straight. And think about the fact that maybe you did the assignment, but didn't do it in a way that caused you to be sure you learned it. And you have to figure out how that is. One thing is, we're sitting there with an example in front of you, keep looking at the example, back to your problems. That's not the way to do it. You digest the examples, then you do the problems without looking at the examples. I mean, sometimes you're going, but you don't, you know, you're doing homework doesn't mean match up the example with the problem without incorporating what's really going on. Okay, that's the first step. You got to do some of that. But you should do some of that in working out the examples yourself without looking at the next step. Okay, try every example, see what you can do on it. That's the way you learn mathematics. Now, everybody has different learning styles, different preferences. So, you know, if those preferences don't match up with what works for you, so be it. Do it in a way that works for you, but make sure you're engaging yourself in the work rather than just basically not exactly copying, because your examples aren't going to be exactly the same as the problems you're working. But yeah, make sure you're doing it right. Okay. Okay, well, now. Just a little introduction. Because you have assignment 1% applications coming up. I think it's due for Wednesday. You have to double check the timing of the assignment, but 30% more than 20 means or 30% more than 70. Plus 30% of 70. Now, one person interpreted this as saying 30% more than 70%. Well, there's no percent on the 70, right? It's a question mark. So if it was 30% more than 70%, you might be right saying it's 100%. Okay, depending, again, there's a little ambiguity in that, but I'm not going to talk about it. Okay, so anyhow, means 70, and then you add 30% of 70. Or means 70 plus 30% of 70. I hope you know the 30% means 0.30. Percent means per 100. If you have 30 per 100, that means you got 30 hundredths, which is 0.30. And now that can be a little bit of a stretch for people who think that percent is a button on your calculator. Okay. And unfortunately, the way math is being taught out there, it appears that that's about what they're learning without really understanding what a percent is. Okay. This is pretty new. But I'm seeing a lot of that, no comprehension of what a percent means. Now, I think y'all probably do have a comprehension. It might not be as good as it could be. So make sure you pay close attention to this, because the whole idea of percent is an intuitive idea. It's important in this course. It's important for understanding numbers, numerical literacy, okay? It's important in life. If you're gonna live in a financial world, you kind of have no choice if you want to survive, okay? So, there we have it. Make sense? So make sure you understand this example, but you're gonna get a lot more in your book, like, I was tempted to put one down that says, 30% more than a number is 150. What's the number? Okay, that's a little hard. Well, you're gonna see that in the book. I might talk about it some. But you're gonna see that in the homework. You're gonna see that addressed in the text. Again, we're moving fast through this stuff. A lot of assignments, because this is all stuff you're supposed to know before you start intermediate algebra. Okay. As I say, I know I've never had a class where people didn't have to do a substantial review of arithmetic and elementary algebra. Not in this class. Okay. So and then this last one. 2x minus 7 equals 4x plus 2. Well, I want to have all the x's on the left and all the numbers on the right. So first thing I'm going to do is 2x minus 7 equals 4x plus 2. I don't upset the balance of this equation if I add the same thing to both sides. Okay. Now I'm going to actually give you a visual demonstration of what this might mean. Okay, that's balanced. I have the same amount of stuff on both sides. I got half the meter stick on this side, half the meter stick on that side. Right? Okay. Now, if I put one of these on this end and one of these at that end, is it going to stay balanced? Okay. These are the same. Actually, they're quite accurate. They're kind of expensive because they're so accurate. But these are each 100 grams, but you don't need to know that. Just that they're equal. There. They're in balance, right? Now, what if I put this on one side, put this on the other? Is it going to balance? No, you know it's not going to balance. So kind of stand here so you can see on camera what happens. No kind of support this. You ready? And release it and take things in balance. Okay. Now, if you've never done something like that, again, it's a lesson that doesn't take long to learn. If you can't hand a few sticks out in class and something to balance them on, and some stuff to put on both sides, takes 5-10 minutes class time, and it clarifies why you can do what you do. So we have this on one side, we have this on the other side. If we add 7 here and add 7 here, it's still, we still have the same amount on both sides. So, okay, so we now have 2x, because negative 7 plus 7 is just 0. So 0, you just take the 7s off. Okay, a negative 7 and a plus 7 balance each other out. We just remove it. We get this. Okay, well, now we've got all our just plain numbers on this side, but our x's are on both sides. What do I have to do now? Well, if I take a four X off of this side and take four X off of this side somehow, okay? Then I'll have all my X's on this side because we do this, we say two X minus four X equals four X plus nine minus four X. So whatever X is, we take four of them off here, we take four of them off here. We take this four, well, we take four off and that balances out the four that were here, okay? Four X minus four X balances out to zero. So we end up with nine here. Two X minus four X is negative two X. Okay. Now, the other thing we can do is we can multiply both sides of an equation by two. I'm going to demonstrate that just to be complete. Okay, so once more, we're in balance. Now, if I double the weights on both sides, well, you know, if I want to double what's on both sides, I don't want to just double these weights because there's also meter sticks, you know, chunks of meter stick on both sides, right? There's half a meter stick on this side, there's half a meter stick on this side. So if I really want to double what's on both sides, what's the easiest way to do this? Probably with this in it. With this in it. Double the meter stick. I double everything on both sides and it's still in balance. Now, the one thing I did. Yeah, I'm looking, you know, okay. There's a little fuzziness about everything I just said, but you get the idea. Okay, so I just multiplied both sides by two. Okay. No, I can't really multiply. With meter sticks, I can't multiply both sides by negative two. Is why I can do that, but pulleys and stuff. Okay. But in this case, I'm going to multiply by negative one half. Well, what's one half of two? Can you show me with your fingers what's half of two? One, right? And a negative times a negative is positive. So this is going to leave me with X. And now with fractions, I just wrote something unnecessary here, but I wrote it anyway. One half times nine is one half times nine over one, right? Nine can be written nine over one. Anything can be written as itself divided by one, because dividing by one doesn't change what you're dividing. So if I multiply numerators and multiply denominators, I get negative nine halves. Well, there it is. Now, one other little comment. These steps here. But also have written them. That one's slided in here. You have negative two X equals nine. Now I wrote it as negative one half of both sides by multiplication, right? It's also possible to do this. Just by dividing both sides by negative two. I don't have to use the fraction. And negative two divides into negative two, giving you one, leaving you X. and 9/-2 is -9/2. So it doesn't matter if I multiply by -1/2 or divide by -2, I get the same thing. Then I check. If I put -9/2 in here, normally I do the check, and I'm going to actually do it. I'll draw some arrows that aren't going to make a lot of sense. Some of the board, but right now they shouldn't. I got x equals -9/2. Bring this up here and substitute for x. Everywhere I see an x. And what do I get? I get 2 times -9/2 minus 7 equals 4 times -9/2 plus 2. Well, being careful, because at this stage of the course, we need to be careful, just because fractions have not been taught as well as they should be. You've got to understand mathematics beyond arithmetic. Okay. Even if you don't understand arithmetic, okay. So I can multiply it out like this. Okay. And then I could rearrange this. This is the same as 2/2 times -9/1, isn't it? I multiply the numerators here, I get the same thing I do if I multiply the numerators here. I multiply the denominators here, I get the same thing I get if I multiply the denominators here. So I can switch the order of my numerators or denominators. And I did it over here too. Okay, same numerators, same denominators. 4 -9, 4 -9, there's your numerator. 1 times 2 or 2 times 1. It's the same thing in the denominator. In this form, 2/2 is just 1. And -9/1 is -9. Then I multiply this, I get -9 minus 7 equals -18 plus 2. -16 equals -16. And now I've checked it, and I know that it's very likely that I've got the right answer. There's a way if you get the wrong answer here and then just coincidentally screw up something in your simplification. Now, the way Open Math is going to show you to do this is going to tell you just to cross out these 2's. Okay. And then cross out a 2 here, cross out the 4, make it a 2 up here. Cancellation. People don't know the rules for cancellation. I mean, most people come out of prerequisite courses not knowing the rules for cancellation. So you better be sure you know the rules for cancellation if you're going to cancel. Because canceling is a whole lot easier than going through all this. But this shows why the 2 cancels the 2. It's because you can rearrange this to have a 2/2, and then it just goes away, and you end up with a -9. And you can rearrange this so that the 2 divides the 4, giving you 2. Multiply that by -9, you get +2. So what cancellation would do is it says 2 times -9/2 minus 7 equals 4 times -9/2 plus 2. And you cross out this 2 and this 2. Then you cross out this two and cross out the four, but write a two there. Okay. Now this thing looks like an eight, so make sure I'm crossed it out. Okay. So I get -9 minus 7 equals 2 times -9 plus 2. And I get -16 equals -16. The problem is people try to cross out this two and this two. I see stuff like that very frequently. Okay. People even try to cancel out the two here with this two over here in a completely different problem. Well, no, they don't go that far, but it wouldn't surprise me if they started. Okay. So people cancel without knowing the rules for cancellation. So make sure you carefully apply the rules for cancellation. Because a wrong cancellation just screws up the whole problem. You almost never get a useful solution if you cancel incorrectly. Now, if you're aware of this and you get a little careless and cancel incorrectly, you get an answer. And don't plug it in and check. You're not gonna learn anything about canceling. If you plug it in and check, you say, oh man, what did I do wrong? Okay, let's say cancel that. Oh, that's not how you cancel. That was dumb. I canceled this two with that two, just I saw a couple of twos and wanted to get rid of them. Okay, I mean, visually, it kind of looks like you ought to be able to do that, doesn't it? And it's very easy to make that mistake. And there are a bunch of other mistakes in algebra that are easy to make. So we want to avoid making those mistakes, and we learn everything by taking a little extra time and checking all the work. Okay. If you check your work, you'll know most of the time when you've made a mistake. And if you know when you've made a mistake, a lot of the time you can go back and fix it, and then you really learn something. You learn much more by correcting a mistake than you do through almost anything else you do. Okay. I know a fair amount of mathematics because I've made so many mistakes. Okay. I mean, there's some truth to that. But I learned to do it without making a lot of mistakes. Didn't stop me from making some. All right, well, there's a little bit about solving equations, which you should know. So you probably do, but it's rusty. So you need to get the rust out. If you don't know, of course, you're going to have to spend more time. And you're probably going to have to do some supplementary problems if you don't really have it. I'm not going to necessarily require that, but I'm going to recommend it if it becomes desirable for you to do so on an individual basis. Okay. Okay, now the assignments that are due, I'm just repeating what I said when the cameras on. Just go ahead and work on these. But the assignments that are due next time are on percent applications and linear equations. So let's just do a couple of fundamental things, very similar to the quiz problems. Which weren't really quiz problems, they were just kind of assessment type problems. See if we can solve these. Show all your steps and all your reasoning. Show everything that you can. Okay, you all are doing pretty well there. Okay, so let me just do these. Again, I'm going to do them in full detail. That's a terrible percent sign graphic. 20 plus 60% of 20. That's what 60% more than 20 means. everybody got 32, but I want to see the reasoning. Because the reasoning is very important. I believe you might encounter problems where you got to write an equation. And if you don't understand how this statement relates to this, you just kind of automatically do this. Well, maybe it's because you do understand, but you want to write out every step simply because when you have to do it with symbols, it gets a little more confusing and you don't want to lose track of your steps. Just advice, but I kind of recommend you take it. Okay, so now here, I've got negative 3x minus 5 equals 7x plus 9. Last time I decided to move the number over on this side by adding it to both sides. But I'm going to take a step that is going to get the x's over on this side. So just to show you it can be done either way. You got your choice. Whichever one you want to pick on first, you can pick on it. Okay. Well, then negative 3x minus 7x is negative 10x, and you still got the negative 5. And 7x minus 7x, of course, is 0. So we just end up with 9 over here. And well, then we have in this case, we add 5 to both sides, because that's going to get rid of the 5 over here, and it's going to appear over here with the opposite sign. And then have negative 10x equals 14. And negative 10x over negative 10 equals 14 over negative 10. I don't have room to write it below, but so x equals negative 14/10. Although, if that's your solution, you put it into open math. Depending on how the problem's been set up, it might or might not accept the solution because it's not in Lowes terms. I can get around that for putting in a decimal, but I don't accept decimals unless I see the fraction first. You want to see the fraction reduced to Lowes terms, go to the decimal. And that's negative 7/5. And of course, that is negative 1.4. And then we check. So we take x equals negative 7/5. Plug it in here and here. And out of that, we get now I'm using 7/10 and 7/5. And it made myself a lot of room there, but there it is. Each x has been replaced by negative 7/5. Not more detail than maybe is necessary, but I'd rather have overkill than underkill. Writing the numbers that are multiplied by the fractions with denominator 1. Make sure that we understand that we're multiplying numerator by numerator, denominator by denominator. I get minus 21. Well, Actually, minus times a minus is gonna give me a plus. I get 21 over 5 minus 5 equals negative 49 over 5 plus 9. Now what am I gonna do? Well, I can put everything over here over common denominator, and put everything here over common denominator. I'm gonna end up with negative 4/5 equals negative 4/5. I'll do that. But there's a better way to do this. I multiply both sides by 5. Okay. Now, it's more steps, but when you end up working it through, then multiply 5 by the 21 over 5. I've also got to multiply 5 by the negative 5. Over here, I've got to multiply the 5 by the negative 49/5 and also by 9. So I've written out what I actually have to do. But if you do it carefully, where you make sure you multiply 5 by everything on this side and multiply 5 by everything on this side, you kind of skip this step, but you want to be careful. Well, if I do that, what's 5 times 21 over 5? Well, that's like 5 over 1 times 21 over 5. 5's divide out, and I end up with 21 minus 25 equals negative 49 plus 45. And now I don't have to deal with any denominators. So my strategy was, I got denominators in this equality and I don't want to mess with it. So I just multiply everything by that denominator. And the denominators go away. I'm going to multiply this by 5, I get 21. We'll multiply this by 5, I get negative 25. Multiply this by 5, I get negative 49. Multiply this by 5, I get 45. Now I have negative 4 equals negative 4. And now I know that I have the right, so I'm 99% confident I have the right solution. Yeah, again, there are ways to make 2 mistakes. Make a mistake in solving the problem, then make a mistake in checking it, and they just happen to come out the same. So try not to make any more mistakes than necessary, and you'll do all right. Okay, now I actually want to take a quick look, slip through the assignment, and see if there's anything else we want to do. Okay, now there is one more thing we want to do on this topic. What do you do if you see an equation like this? Well, as I said earlier, I just now in checking that last problem, I've got an equation, I can get rid of the denominators. Okay. And the denominators can be confusing. You're probably more likely to make a mistake if you have an equation that includes denominators than if you don't. Most of the time, I believe that's true. So what I'm going to do here is I'm going to exercise a little bit of overkill, and I'm going to solve this problem. Okay. I'm gonna multiply both sides by, oh, let's say, 90. Okay, why did I pick 90? Well, 90 is not the best number to pick, but it's gonna work. Okay? Now, let's see, what do I do? I have to use a distributive. I have to multiply both sides by 90. And to multiply everything on both sides by 90. So I have 90 times x over 3 plus 90 times 5 equals 90 times x over 2 minus, might be a little hard to read, I didn't leave myself enough room, but 90 times 3. So it should be clear what I've written. Okay. Now, and only now. This looks like it's big. I put a 1 under my 90. I'm not totally comfortable, but that's not really necessary. This can be arranged 90 over 3 times x over 1. And 3 can divide the 90, leaving me 30. Everything else is a 1. So I get 30x. In other words, 90 multiplied by x minus 3. 3 divides the 90, I get 30x. And 90 times 5 is 450. And then 90 times x over 2. Well, I divide the 90 by 2. I get 45x. And 90 times 3 is 270. Okay. Well, now, subtract 450 from both sides, and I get 30x equals 45x minus 720. And then I want to get my x's in the same sides, and then subtract 45x. Let me write that out a little more clearly. So subtracting 45x from both sides, 30x minus 45x is negative 15x. The 45x and the negative 45x add up to 0. I get negative 720. So I find that x equals negative 720 over 15. And something's terribly wrong because that number is way too big. Negative 48. Must have been something wrong. I plugged negative 48 up here. Oh, wait a minute. No, it doesn't check. Anybody see my mistake? Okay, now I'm not going to write out the check. I'm just going to say the check fails. So that can't be the right solution. Oh, wait a minute. I said negative 48. I divided by negative 15. So that gives me plus 48, which I think is going to make me happier. 48 divided by 3 is 16. 16 and 5 is 21. 48 divided by 2 is 24. Subtract 3, I get 21. Okay. I really did that. I'm not just, didn't just pretend to do that to show you what you ought to check. I really demonstrated why you ought to check. I couldn't see it. I was looking everywhere. I didn't look at this last step and notice that I had divided by something besides -15, right? And what I really should have done here is I should have gone from this step to this step. So I'm gonna wipe that out. I skipped a step. And I demonstrated why you shouldn't skip steps. I was busy talking and I didn't notice the negative sign of the 15. Well, what I should have done is I should have written -15x over -15 equals -720 over -15. So that x equals 48, not -48. And the check is very simple. It doesn't take many steps. I just plug 48 in for x and divide it by 3 here, divide it by 2 here. I get numbers that add up to the same thing. Okay. All right. So my point is, I went directly from this step to this step, but look, didn't write the negative under the 15. If I had written this step here where I've got -15 divided on both sides, it only takes a few extra seconds to do that, and I'm much more likely not to make a bonehead error like I did. Okay? If I can make that mistake, you can make that mistake. Okay, well, now the point of this is, look, it actually ended up with kind of big numbers there. So I had to do some arithmetic. You probably need a calculator to do some of it. I don't know. If you're good with the arithmetic, you can probably do it in your head, but the numbers are too big. You know what happened? Multiplying by 90, 3 goes into 90 and 2 goes into 90. So I end up with just plain old numbers in front of X. Is that clear? So all I really want is a number that you can divide by 3 and also by 2. How about 18? Can you divide 18 by 3? Yeah. Can you divide 18 by 2? Yeah, but 6 is the smallest number that divides both of these. So what I do is multiply by 6. With this. 3 divides a 6 twice, I get 2x plus 40 equals, should have been a 2 here, now a 3. 3x minus 18. And now I've got an equation just like the ones we've been solving with no fractions. And it's easy to solve. So I clear the fractions first. This is the least common multiple of 2 and 3. And that clears the fractions. We end up with something that's easy to work with. no denominators to worry about.